aluminum. I'm going to take probably the bandsaw, I'm going to rough cut it to close to my dimensions that I need it to. Then I'm going to take it on a mill, which here's my mill here, and then I'm going to mill it to the exact dimensions I need it. Maybe not quite exact, because then I'm going to take it to a polisher or a grinder and get it to that precision. Now when I say precision, if you guys think about like a wood shop or a carpenter, like their precision is maybe a 32nd is the closest they're going to need to get to. Typically a 1/16 of an inch. When I'm talking precision in here, you're talking hundreds of thousandths of inches. So like, especially in the aerospace industry, you can't be a ½ inch off when you're making a plane. You agree? Probably wouldn't be a good thing. Would you want to fly on that plane? No. So you got to be very precise. That's where the math comes into play. So let's say a practical application of this. I brought a toy in that I made back when I was in college. So I take a raw piece of aluminum here, just a cylindrical piece of aluminum. I would put this on a lathe and I would machine this. I'd taper this edge. I use some knurling here just for grip, and then thread this here so that I would then take my piece of brass. I'd machine it on a mill, one of these mills here. Put a little feature into it, just a couple of chamfers in there, and then I thread that, so then now I have a brass hammer. So that would be like a practical application of what you would do in here, like as far as making parts. The industries that use this is, you got the aerospace, the automobile industry, so you'd be making different parts for maybe Boeing, Patriot Machine is a big company. Now these companies, the reason why Lewis & Clark is doing this is because these companies are asking Lewis & Clark, can you have this program so we can properly train these kids to either come straight out of the tech school into a job, or to go right to Rankin with background knowledge, get an associate's degree, and then go into a job, because this field is in high demand right now. Right now the average, most of the age of the people in this industry is in their upper 40s to their 60s. So 45 to 60 years old, what are they going to be doing here in a few short years? Retiring. So they're going to need to replace that. In this part here, so machinist right here, where you're actually standing in the machine doing all the physical labor yourself, you're going to make anywhere from probably $25 to $35 an hour when you're starting out, depending on the company you're working for. And then as you get good and you've been there for a while, you can make anywhere from $35 to $45 an hour. Some of the background, my dad's been in this industry for 36 years. He's actually retiring on Friday. And I can tell you, he makes over $100,000 a year in this industry. He started out as a machinist doing this, making like $8 an hour. Now that was 36 years ago, so that was good money back then. And then he went into designing, so then he actually started doing this a little bit, designing the drawings, or what you're going to make. And then he went into management, that's where he kind of gained some of how he's making some of his money. So here, you're all manual. You're doing it all yourself. So if you walk over this area, these are called CNC machines over in here. What a CNC machine is, CNC stands for computer numerical control. What this is going to do is, you learn how to take that drawing, program it into here. You program all your set points of basically where a tool is going to start, where it's going to stop, and the path it's going to go. In here, this is basically rated as a 20 tool changer. That cylindrical area, you see some things sticking down, those are all different tools, different mills that you would put in there, and it houses 20 different tools. So basically, I can have this program, if I have a part, now this obviously doesn't use 20 different tools, it maybe uses about 4 or 5. So I would program it to where it would do all of this. I would take this rough piece of, let's just pretend there's no holes in here. It would take this rough piece of aluminum, just this square piece of aluminum, and then after it's done, it would basically create this. How it works is, though, it would stop at each time you have to change the tool. So this one would need to stop, you need to go in and change the tool, and then you hit start, and then it restart back up. It's housed in this because whenever you're working with metal, you have to use cutting oils or coolants. You can't just take a piece of metal and cut into metal without using a coolant. You'll damage the bits and different things like that. Just that little bit of liquid cools it enough to where it doesn't damage the fits. They have bigger machines than this, so this one you actually have to physically manually change the tool. They have machines that are the size of this wall, that what you do is you program it, you hit start, you come back 10 hours later, and you have a part, or however long it takes. And it automatically changes the tool for you. We went to